This is a demo of Conjur security controls for Kubernetes. Here's the Kubernetes Ui, which comes with the Kubernetes server. Kubernetes is a container cluster manager. What this means is that developers can package applications into deployable packages called container images and push them into Kubernetes. Kubernetes will configure and start as many copies of the containers as the developers ask for. If a container crashes, Kubernetes automatically relaunches it somewhere in the cluster. Using Kubernetes, complex applications can be quickly deployed and scaled, using a workflow which is much faster than with virtual machines. Kubernetes is composed of master servers and node servers. In the simplest case, called Minikube, the master and the nodes are a single machine, but for real scenarios, the master is a redundant cluster, and there are many nodes. Currently, Kubernetes claims support for up to 1,000 nodes. For management purposes, Kubernetes is separated into namespaces. Namespaces can be used to keep applications and services separated from each other, for example, into development stage and production environments. In Minikube, there are two namespaces. Kube system is used by Kubernetes itself. Default is used for all the applications. There are different ways to deploy applications into Kubernetes. Among them are deployment, which is used to specify how many identical copies of an application should run for scaling purposes, and stateful sets, which are used for clustered applications like databases, whose processes need to carefully coordinate with each other. From a security standpoint, what's important is the following. First, namespaces are a way to divide Kubernetes up into non-conflicting segments. Second, deployments and stateful sets are logical applications or services which need to have identity and use privileges. To show how Conjur provides improved security for Kubernetes, we're going to use an example application called Inventory. Conceptually, the inventory application manages product inventory in a backend database. For this simple example, InventoryDB is a database that has a password. The inventory app uses the InventoryDB password to connect to the database. The InventoryDB may run inside or outside of Kubernetes. The inventory application and database are deployed in Kubernetes, but their security aspects are managed in Conjur. Inventory is modeled in Conjur by a policy, which defines an application layer. The database password is also stored and managed in Conjur using the InventoryDB policy. In standard fashion, the inventory layer is given read and execute permission on the password. When the inventory web page is loaded, the inventory code will try and fetch the database password from Conjur and print it to the screen. These actions will generate audit records in Conjur. You may be wondering, what about Kubernetes secrets? In case you didn't know, Kubernetes has a feature called secrets. However, Kubernetes secrets management capabilities are very limited. First off, internally, Kubernetes stores the secrets in plain text, not encrypted. Secrets are also transmitted in plain text between master nodes. Next, access to secrets cannot be restricted on a per-user basis, so access to the entire Kubernetes system must be restricted to highly trusted personnel, which limits its usefulness as an agile tool. Kubernetes also does not keep an audit record of the secrets, so there's no way to find out after the fact who created a secret, who updated it, and who fetched it. Using Conjur as the secrets provider for Kubernetes solves all these problems. The secrets are always encrypted, both at rest and in transit. Access to secrets, along with read and write privilege levels, is tightly controlled using role-based access control, and all access to secrets is recorded in the Conjur audit log. Furthermore, once Conjur is integrated into Kubernetes, it can also provide additional security capabilities. For example, Conjur can provide fine-grained web service access control. It can also provide authentication and authorization for the Docker registry, which is a critical component of the full container orchestration system. And Conjur can manage secrets and SSH access for the Kubernetes cluster nodes themselves via integration with tools like Puppet. When an application is initially loaded into Kubernetes by the developer, it has no privileges in Conjur. Therefore, visiting the inventory page prints the error 403 forbidden. This error is printed because the application does not yet have any privileges. It does not have permission to access the database. In my console, I have a directory with scripts called interventions. Each of these is an action that can be taken to manage the security controls of the applications in Kubernetes. When I run enroll app, this adds the Kubernetes inventory host to the inventory layer, which gives it the permissions that it needs. Once the app is enrolled, visiting the inventory page prints the database password. The Conjur audit keeps a record of the activity. When I look at the audit record, there's a record showing that the host passed a check to execute the inventory password. The host is the identity that is used in Kubernetes by the application. If the database password is compromised or it needs to be rotated for some other reason, rotate database password intervention changes the database password to a new random value. Database passwords can also be rotated automatically on a schedule by Conjur's rotation service. After rotation, the inventory application will pick up the new password when it's reloaded, and Conjur will show the audit events showing the admin updating the inventory password and showing the application refetching the password. Next, we will look at a developer named Dan. When Dan is initially added to Conjur, nothing in Conjur is visible. No hosts, no secrets, no layers, no policies. Dan is in the system, but he does not have any privileges. Dan can be added to the inventory application using the enroll developer intervention. Dan can now see the Kubernetes hosts and also the password. This action is reversible by revoking the group membership, revoke developer. If there's a suspicion or knowledge that an application has been compromised, or if the application is simply end of life, revoke app will move the Kubernetes application out of the inventory layer. Refreshing the page again, the application is not permitted to get the database password. The reverse is enroll app. In case there is a deep compromise of the cluster, there's also a kill switch for the entire Kubernetes namespace. With a single command, all the apps and services in the namespace can be prevented from authenticating with Conjur. And as a result, the application's access to the password is again forbidden. This command takes out every single app in the namespace. Again, it's easily reversible. That concludes our demo of Conjur security controls for Kubernetes.